Hello buddy, Senior Engineer, MBA and investor, and in today's video I want to talk about how Mark Zuckerberg has invested in CRISPR. But before we do that, before we jump into today's video, I do want to talk about our sponsors. No, I'm just kidding. I think from last video a lot of people got a few people got annoyed by that sponsor comment. I was just literally talking about how the products I was sent was amazing, but obviously they're not official sponsors, just FYI. So anyways, we'll jump straight into this article on MIT Technology Review. Basically, it is an article that was published yesterday, and its title has "This CRISPR Pioneer Wants to Capture More Carbon with Crops." New research at Jennifer Doudna's Institute aimed to create faster-growing, carbon-hungry plants using the gene editing tool, which of course is CRISPR. So we'll take a look at this article here. Let's try to zoom in here. Plants are the original carbon capture factories. Our new research programs aims to make them better by using genome editing. So obviously this is the correct statement, and obviously if you can accelerate that efficiency and maybe make them even capture more carbon using CRISPR, that is of course a win-win, and I believe that is the goal here. The IGI, which obviously we've covered the website many times, founded by CRISPR co-inventor Doudna, has announced a new program to use revolutionary genome editing tool on plants to boost their aptitude for carbon storage. The initial program will last 3 years, and it is funded by an $11 million grant from Mark Zuckerberg and Priscilla Chan's foundation, obviously Chan being the wife of legendary Mark Zuckerberg, and of course Zuckerberg is the CEO and founder of Meta, formerly known as Facebook. The research is part of a growing effort by scientists to find ways to vacuum up carbon dioxide already in the atmosphere to slow climate change. Upping natural abilities of plants to take carbon dioxide could, if done on a large scale enough, help push down peak temperatures in a warming world. So obviously if you want to reduce carbons in the atmosphere, you sort of up that natural ability for plants to capture carbon. Looks a little bit optimistic, but of course with CRISPR, we've mentioned it many times in the past, vegetation should be literally the first avenue, in my opinion, that a lot of these companies should look at. I think human therapeutics is definitely novel, it's definitely noble, it's definitely needed, and I think it's absolutely something that we want to venture and invest and put resources in. But there's so much we can do with climate change. There's so much we can do with vegetation, crops, and fruits. We're talking about using synthetic meat, maybe reducing our footprint, our dirty footprint on this planet by just literally using technologies like CRISPR. And CRISPR won't be the one single tool to make it all happen. Obviously, it won't be this one single tool to make it all happen. There'll be multiple of tools that will have to be used here to have something in it as an outcome where you can have lots of crops that can sort of up their carbon capture game. But obviously here for this particular program, we're focusing on CRISPR and we're focusing on carbon, and how CRISPR can literally make these crops capture carbons a lot more. And obviously they're going over some of the primary goals here. Tweak photosynthesis so that plants can grow more quickly. So it's actually they want to fasten here the plant's growth. That's pretty interesting. They want to alter the enzymes here so they could actually release. Okay, photosynthesis is only half of the story, because carbon in the plants usually makes its way back in the air after the plants are eaten by soil. So that is true. Keeping carbon in the soil or finding other ways to store it, or at least as important as capturing in the first place. Okay, yeah. I don't really agree with that statement, but okay. Because you could sort of, define a region where those plants, actually, if those plants die down, or, they'll release it back. But anyways, I don't think it's half of the story, but whatever. Larger deep root systems can help store more. Yeah, actually, that's true. Because if a plant dies and part of it is underground, that the carb in those pieces is less likely to make its way back into the air quickly. So the first thought here is like oil, right? How oil is stored in the ground, and the only reason why we're having this problem is because we're pumping oil all the way back in our surface here and release in the air, right? So, okay. Optimizing plants for carbon removal will be challenging. Okay. Many of the traits want to alter in plant are influenced by multiple genes. Okay, yeah, so that's definitely multiplexing here. That's definitely difficult. While some plants like tobacco and rice have been so extensively studied that researchers broadly understand how to tweak them, the genetics of others are well less understood. Of course, if you don't put time and resources, then of course they'll be less understood. Rice is actually really understood. We have lots of CRISPR study on rice, actually. At the same time, the Institute will work on developing better genome editing techniques. Okay. The team, I hope they eventually, with 11 million, 3 years horizon, I don't know how much you can get done, but I think you can get a lot done there. Okay. Plants or microbes can be actually part of the solution rather than part of the problem. Okay. Yeah, some of these statements are very generic. But that's pretty interesting news, guys. An article from MIT Technology. I wanted to cover this article for two reasons. First of all, it's a beautiful initiative. I think whatever IGI is doing, of course, under the helm of Doudna there, I think it's amazing. It's noble. I really, really am looking forward for more CRISPR involvement outside of human therapeutics. I mean, human therapeutics has been very vital to our channel. We cover all these companies covering this space, but of course, vegetation, animals, plants, fruits, rice, tobacco, all of that. It's something that you want to explore and put resources into, knowing the power of a tool like CRISPR, right? Which we believe in this channel will be here for the following years, if not decades, right? But the second biggest news here, of course, is that this program is funded by Mark Zuckerberg. Although it's only $11 million for Zuckerberg, obviously it's like peanut change. But for the average Joe, obviously 11 million is a lot. And I would assume that 11 million for a program that's only being lasted for 3 years should be enough to sort of have a proper study where you can sort of develop a thesis and maybe test it out. So we'll take a look and we'll keep our eyes on this type of study here. Again, it won't play out anytime soon. But very exciting that a founder and CEO of a huge tech company is really involved here. But obviously Zuckerberg wouldn't be the first CEO that is involved in CRISPR. Refer to our video with Mammal Biosciences and Tim Apple, or known as Tim Cook. So thank you so much for watching, guys. I will end this video like this. Let me know in the comments below what you guys think about this article here. Subscribe if you have not. Like this video if you found value. And once again, my sponsors are... No, I'm just kidding. Have a good day. Have a great day, guys. Thank you.